Welcome to The Explainer. Today, we're diving deep into Envoy Proxy. You know, when you think about these massive applications from companies like Lyft or Google that handle millions of requests without even blinking, a huge part of that magic is Envoy. It's really the unsung hero of the modern cloud, and we're going to pull back the curtain and see exactly how it works.
So let's kick things off with the big question, the one that architects and developers are dealing with every single day. As your applications break up into more and more services, how do you manage all that traffic, keep it secure, and actually know what's going on without stuffing all that messy logic into every single service?
So, here's our game plan. We're going to start with the fundamentals. What even is Envoy? Then we'll get into the 4 core building blocks that make it tick. From there, we'll see it in action with a really cool case study. Check out its powerful security features, and then zoom out to see the advanced ways it's shaping the entire industry.
All right, let's jump right into Section 1. What is Envoy Proxy really?
At its core, Envoy is an incredibly high-performance proxy written in C++. Now, it was born at Lyft to solve their real-world, massive-scale traffic problems, but it's grown way beyond that. It's now a cornerstone project at the Cloud Native Computing Foundation. It's truly built for speed and for scale.
And this is where things get really interesting. See, Envoy isn't just a simple pipe for data. It's smart. It understands modern application traffic like HTTP/2 and gRPC. It gives you amazing visibility, or observability, with built-in metrics and tracing. You can even extend it with your own custom logic using WebAssembly. But honestly, the absolute killer feature is its dynamic configuration. You can completely change routing, security policies, anything, all without ever restarting the proxy or dropping a single connection. That's a game changer.
So, how does Envoy actually pull all this off? Well, to get it, you really only need to understand 4 key concepts. If you can get your head around these 4 building blocks, you'll understand the entire philosophy of how Envoy handles traffic.
Just think of these 4 things as the journey every single request takes. It starts with a listener, then it gets processed by a filter chain, it finds its destination from a route, and it finally lands at a cluster. Listener, filter chain, route, cluster. Let's look at each one.
First up, the listener. This is the front door. It's as simple as that. It grabs a port, like port 443 for HTTPS traffic, and its only job is to listen for and accept incoming connections. Everything starts here.
Okay, once the listener accepts that connection, it passes it off to a filter chain. And this is where the magic really starts to happen. It's a pipeline of actions. You can have a filter that handles TLS decryption, and then the next one in the chain checks a JWT for authentication, and maybe another one adds a header. You get to build this custom processing pipeline for your traffic.
So after the filters have done all their processing, the request needs to know where to go next. That's the job of the route. Think of it like a traffic cop. It looks at the request, maybe the URL path or a specific header, and uses that info to make a decision about which backend service should get this traffic.
And finally, the request reaches its destination, a cluster. Now, a cluster isn't just one server. It's a logical group of all of your backend servers for a specific service. Envoy knows about all of them, and it'll intelligently load balance the request across all the healthy hosts in that cluster.
All right, that's enough theory. Let's make this real. We're going to walk through a case study from the source material that I think really brings this all to life. A high-performance URL shortener that uses Envoy to direct its traffic.
What's so clever about this architecture is that instead of having one big Envoy proxy try to do everything, it uses 2 specialized tiers. You've got a main gateway that handles all the regular user-facing stuff, but then it has a separate, super streamlined Read Proxy that's optimized for just one thing, making URL redirections happen as fast as humanly possible.
So let's look at that main gateway. The routing here is pretty straightforward, right? A request comes in for /API/v1/shorten. It goes to the right service. If it's for analytics, it goes to the analytics service. Anything else just goes to the main front end. Classic, simple, path-based routing.
But now for the read path, the really high-performance part. When someone clicks a short link, we need to be more precise. We can't just match on a prefix. We have to perfectly capture that unique shortcode from the URL. And for that, we need a more powerful tool.
And there it is, a regular expression. Now don't worry about the syntax. All this pattern is doing is making sure that the request path is a slash, followed by one or more letters, numbers, dashes, or underscores. That's it. It perfectly matches a valid shortcode and nothing else. And when it finds a match, it sends that request straight to the hyper-optimized Read API service.
Okay, so getting requests to the right place is one thing, but you also have to protect those services. And this is another area where Envoy just absolutely shines, basically acting as a security guard for your whole system.
This right here is fantastic. Instead of making every single one of your backend developers write code to validate authentication tokens, you just push that logic out to Envoy. It checks the token right at the edge, and if it's valid, it can even pull out useful info, like the user's ID, and just pass it to your backend in a simple, trusted header. This makes your backend code so much cleaner and simpler.
The URL Shortener also uses this awesome two-layer approach to rate limiting. First, you have local rate limiting. Each Envoy proxy keeps its own count, in memory. It's blazing fast. But for a true system-wide limit, they also use global rate limiting, where all the envoys talk to a central service to make sure one user can't hammer your system by hitting different proxies. It's a great defense in depth strategy.
You know, so far we've mostly seen Envoy acting as an API gateway, but its capabilities go so much further. Let's just touch on how it's being used as a fundamental piece of the puzzle in some much more sophisticated patterns across the industry.
This really gives you a sense of just how flexible Envoy is. It's the engine, the data plane for service meshes like Istio and Linkerd. It's what lets you do complex things like canary deployments. It gives you deep observability, and it's constantly making sure your traffic only goes to healthy services.
And this is a perfect example of how Envoy keeps your system resilient. It does health checking in two ways. There's active checking, where it constantly pings your services to see if they're okay, but then there's passive checking, or outlier detection, which is even smarter. Envoy just sits back and watches the real traffic, and if it sees one of your servers suddenly start throwing a bunch of errors, it will immediately and automatically pull it out of the rotation for a little while. It protects your users from a failing instance before you might even know it's failing.
You know, when you boil it all down, the big idea is captured perfectly in this quote from the source material. Envoy is so much more than a load balancer. It's a programmable foundation for your network. It's a place where you can move all that complex logic, the retries, the security, the circuit breaking, out of your application code. And that means your developers can stop reinventing the wheel and just focus on building great features.
We've really just scratched the surface today, but it leaves us with a really powerful question to think about for our own work. Just think about it. What complex, repetitive logic is currently cluttering up your own services that you can offload to a programmable network layer like Envoy? The possibilities are pretty amazing.